Hello everyone. Welcome to this lecture number 2 of this Unit 5 Flexible Manufacturing System. This is Mr. Suyog Patil working as a system professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Edrao, Chalkanji. Today we are going to see this introduction to the group technology. Okay, today we will see this group technology. What is meant by this group technology? Then again, what are the benefits of this group technology? Advantages, limitations. We will see in this lecture. Okay, first of all, what is meant by this group technology, and what are the objectives of this group technology? So there are two things. One is batch manufacturing is estimated to be the most common form of this production in the United States. Okay, constituting more than 50% of the total manufacturing activities. So in the world, or this is the scenario of this United States, but in the globally as well, as there are two main things. One is batch production system and mass production system. Okay, in this batch and this, out of these two, the batch production system is more conveniently used. Okay, so it is the one thing. And second thing is that it is important to make batch manufacturing as efficient and productive as possible. Okay, so batch manufacturing is more as compared to those other processes. So therefore it is necessary to make this manufacturing process efficient and productive as possible as. Okay. And also there has been a trend to integrate the design and manufacturing functions in the firm. Okay, so from these two point of views, or by considering these two objectives, this new term or new approach is directed, and that is called as group technology. Okay, GT, group technology. So we will see what is meant by then group technology. So this term group technology was first used in the early 1950s. Okay, it is born in 1950s. This technology is a manufacturing philosophy in which similar parts are identified and grouped together to take the advantage of their similarities in the design and production. Okay, so in this group technology, so the similar parts are identified and they are grouped into the various part families. Okay, and this similar parts similarity can be and identified by considering their similarities in the size, shape, or the geometries, then similarities in the functions, part function geometry. Okay, then again similarities by considering their manufacturing technology or manufacturing processes required. Okay, and these similar parts are identified and grouped together. Okay, to take the advantages of their similarities in the design and manufacturing. Then again, the similar parts are arranged into part families. Okay, where each part family possesses similar design or thus manufacturing characteristics. Okay, but considering these two main things, that is in the similarities in the design process or similarities in this manufacturing activities, so their part families are classified, and these similar parts are arranged, are grouped together in these various part families. Okay, so we will see one example here. A plant producing 10,000 different parts, different part numbers. Okay, may be able to group the vast majority of these parts into 30-40 distinct families. Okay, these 10,000 parts can be classified into these 30-40 distinct families of this part. Okay, then again it is a reasonable to believe that this processing of each member of this given family is similar, and this should result in the manufacturing efficiencies. Okay, so to improve this manufacturing efficiencies and this production efficiency, so these parts are similar parts are grouped together. Okay, and these 10,000 parts can be grouped into these various part families, 30-40 various part families. Okay, so this is called as group technology. So here we can see pictorial view of this group technology. So here these are the random parts, randomly placed parts. Okay, and these are the grouped parts. Okay, after grouping and before grouping. So what will happen because of this grouping, or by applying this group technology? this identification time or to finding out this time is reduced, okay, and automatically this production efficiency increases because of this grouping of these parts, okay, and we can see the from this vectorial view. Then implementation of this group technology. Okay, so there are two major tasks that company should undertake understood and while implementing this group technology. Okay, and these two main or we can say the significant obstacles while applying this group technology. Okay, and these are identification of the part families and arranging the production machines into the machine cells. Okay, these are the two main tasks, or we can say these two main significant obstacles in this application of this group technology. So identification of the part families means if the plant takes makes 10,000 different parts and reviewing all the parts drawings and grouping these parts into families is a substantial task. Okay. And it consumes a significant amount of time. So this differentiating these parts and making this group of the different parts of these 10,000 produced parts, it requires more amount of time. Okay, it requires more amount of time while identifying these components. So it is one of the challenge, or again we can say it is the one obstacle while implementing this GT. Then second one, it is rearranging the production machines into machine cells. Okay, so again it is a time consuming and costly plan to accomplish this rearrangement of the machines. Okay, so rearranging these production machines takes more time as well as it is a costly or it requires more space. Okay, so as well as the machines are not producing this components or machines are idles or stopped while doing this rearrangement of this plan. Okay, so these are the main again two obstacles in this GT implementation of GT. So some of the benefits of this group technologies are listed here. Okay, so this GT is a management strategy to help estimate this waste caused by the duplication of the efforts. Okay, so by identifying the similarity, we can avoid this duplication and we can eliminate the waste. Okay, and again, this manufacturing efficiencies are also improved. Okay, manufacturing efficiencies are generally increased by this GT. Then this GT promotes standardization of the tooling, fixtures and setups. Okay, this group discussion, identification and sorting and this grouping may help to standardize this tooling, fixtures and startups. Then material handling is reduced because of this, because the distances within the machine cells are much shorter than this within the entire factory. Okay, so machines are grouped together and placed within the shorter distance. So material handling required in this factory is less, or material handling is required reduced. Then process planning process planning and production scheduling are also simplified, okay, with the help of this GT. Setup times are reduced, resulting in lower manufacturing and lead times. Okay, because of this improved efficiency and this time required for manufacturing can be reduced. Work in process is reduced. Then worker satisfaction usually improves when workers collaborate in a group technology sales. Okay, so material handling is less and other identification or finding out this components is less in this GT. So this worker satisfaction is also there. Then higher quality of work is accomplished using this group technology. We can achieve this higher quality work in the with the help of this GT. And again, it reduces the number of variety of the parts. Okay, number of variety of the parts are can be reduced here. Then this group technology can also affect the various areas of these companies. Okay, including the engineering, that is reduction of the new and similar parts and drawings. Then the equipment specification, facilities planning, process planning, production control, quality control, purchasing and service of these industries. Okay, so this group technology can affect. So these are the various benefits of this GT. Similarly, some of the limitations of this group technologies are also there. So first one, it is problem of identifying part families among the many components produced in the plant. Okay, this plant Delhi plant is manufacturing more number of these parts, and identification of the similar parts or these parts families and grouping these parts is very challenging. Okay, so this is one of the problem, or this is one of the limitation of this GT. Then again, it is a time consuming and expensive process. This group technology requires more time, and it also additional, it incurs additional cost as well as, okay, the expense of the parts classification and coding as well as there. While classifying these parts and additional coding is required in this group technology, so it incurs additional cost, and this cost is very high. Then rearranging the machines in the plant into the appropriate machine cells. Okay, so while applying this group technology, again, um, we have to identify the machines by considering their manufacturing processes. Okay, and we have to arrange these machines into a machine cells. Okay, so again, it requires more time as well as it incurs cost as well as. Okay, so this is also one of the limitation of this group technology. Then now we have seen this introduction to this group technology. Okay. So in this group technology, again one more term is important, that is part families. Because in this group technology, we are identifying the similar parts and we are making their, we are forming their groups. Okay. And this group is nothing but this part family. Okay. So part family is a collection of the part that are similar either because of this their geometric shape and size, or because of this similar processing steps required in this, required in their manufacture. Okay, so there we can say, as we seen in earlier, according to their geometries, size and shape, or their materials, and or again we can say their manufacturing processes required. Okay, so this similarity is considered, and they are formed in different families. The parts within a family are different, but their similarities are close enough to merit their inclusion as a member of their part family. Okay, so we will see here in detail. So these are the two families, part families. Okay, so in this first part family, two parts are identical shape. Okay, these two A and B parts are identical in shape and size, but different manufacturing requirements are there. So that means the material of the these two components is different. Okay, so material of the component is different, but size and shape of the component is same. So therefore we can group, or we can form a one part family for these two parts. Here in the second part family we can see, so these are the various components which are produced by a turning process. Okay, so therefore this manufacturing process requirement, that is turning, is similar here. Okay, a part family having similar manufacturing processes required, but the different design attributes are also there. So sometimes some on the some components like here and here, milling is required, milling operation is required, some drilling holes are required here. Okay, so therefore some design attributes are different here, but we can form a part family of these parts. Okay, so by considering these design attributes and the manufacturing attributes, again we can form these part families. Okay, so here, so this category is based on these design attributes and manufacturing attributes. In these design attributes, these are concerned with these part characteristics such as geometry, size, and material of the component. But in case of these manufacturing attributes, these are concerned with these processing steps required to make this part, or the operations required to produce that particular part. Okay, based on this, we can categorize these part families. So part design attributes. First of all, design attributes. Okay. So these design attributes includes all these points. That is basic external and internal shape of the component. Okay. Then rotational or rectangular shape, this particular size or shape of the component. Length to diameter ratio. Okay. For in case of this rotational parts, aspect ratio, length, width, height. Okay, and proportionality in case of this rectangular parts. Okay, this aspect ratio. Then material type, part function, major and minor dimensions of this components. Okay, again all this comes under this design attributes. The tolerances given or provided on the component, surface finish of the component is again comes under this design attributes. Okay, similarly, For part manufacturing attributes, again this major and minor operations required or processes required to produce that component. Okay, based on this, again manufacturing attributes are defined. Then operation sequence is again very much important while identifying these part families. Then major dimensions, machine tool, production cycle time, batch size, then annual production, then fixtures required for this holding this component, cutting tools used in the manufacturing system. Okay, based on these again, this manufacturing attributes can be defined. So part family formation. Okay. So the biggest single obstacle in challenging over this group technology from conventional production shop is the problem of grouping the parts into families. Okay, and these are this part family formation. One of the biggest challenge in this implementation of this group technology is formation of these parts. Okay, or grouping these parts, and this can be so this problem method of this problem can be solved by these methods. And visual inspection, part classification and coding, production flow analysis are the three methods to implement this group technology. All these three methods are time consuming and involve this analysis of much data by properly trained person. Okay, this is again requirement of this group technology. And visual inspection, first method is visual inspection. This method is the least sophisticated and least expensive method. Okay, this visual method is least expensive and least sophisticated method, and as well as it is less accurate as well as. Okay, and again it involves the classification of the parts into families by looking at either the physical parts or their photographs. Okay, and arranging them into groups having similar features. So here we can see, so these are the four parts families are defined in this first part family. So triangular components are placed here, circular components in the third, it is rectangular components are placed, and some other components are placed here. Okay, this is after grouping or grouped parts, and this is before. Okay, parts before grouping. So therefore when we form this such type of this families and when we group these parts, okay, so automatically efficiency of this production or efficiency of the manufacturing can be improved. This method is generally considered to be the least accurate method. Okay, and this method is fast and simple and useful when this part mixture is not complex. In case of the simple components or simple parts, so this visual inspection method can be used. Second method is part classification and coding. Okay, this method is the most time consuming method of all three methods. Okay, and this part classification and coding, again its similarities among parts and parts are identified, and these similarities are related in a coding system. Okay, based on their similarities this parts coding is done. Okay, and part classification and coding requires more time, and based on this coding, so this grouping is done in this second method. In the third method, production flow analysis is a method for identifying part families and associated machine grouping. Okay, and that uses this information contained on process plans rather than on this part drawing. Okay, in this third method, this method based on this process plans. Okay, it is not based on the part drawings, part similarities, but it is related with this manufacturing similarities. Okay, manufacturing attributes. So this work parts with identical or similar process plans are classified into the part families. These families can then be used to form logical machine cells in a group technology layout. Okay, so this group technology layout, these machine cells are in, arranged in a logical forms, or this in this production flow analysis it is mainly focusing on this manufacturing sequences. Okay, so therefore this grouping is done based on this production flow analysis. Then again the procedure in production flow analysis must begin by defining the scope of the study, then which means deciding on the population of the parts to be analyzed. Okay, based on this third method can be implemented. Okay. So here in this video, what we seen is what is meant by group technology, then how it can be implemented in this manufacturing processes, and how it affects, what are the benefits and some sort of this limitations of this group technology. Okay, and the methods of implementation of this group technology. Okay, so we will continue in the next lecture. Thank you so much. Friends, thanks for watching this video. If you like this video, please share, comment and like this video. Then subscribe to my YouTube channel and click on the bell icon to get notified for more videos on this CAD/CAM subject. And thanks for watching. Thank you. Thank you so much.